Now that we've spent some time looking at quadratics, we're going to look at some applications today. So the first example, if you throw a ball or shoot an arrow, fire a missile, or throw a stone, it will go up into the air, slowing down as it goes, and then it will come down again. And a quadratic equation tells you where it will be at any given time. So let's look at the first example. A ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters a second. When will it hit the ground? Can you sketch a graph of the height of the ball over time? Label each of these on your axes. Okay, so let's draw a picture of this with our axes first. Okay, so here's the height of the ball over time. Oops, my workspace quit. Let me try this again. Okay, so again, here's our graph, and our ball will start 3 meters above the ground, and it will go up, and then it will come down. And we have certain spots here that we need to label. So again, this is the height over time. Label the line of symmetry. All right, it is a parabola, so we have our line of symmetry, or the mirror line. Where is it cut in half? All right, so here's our mirror line of symmetry. Our minimum would be right here. This is also the x-intercept. Our y-intercept is right here at 3. Our maximum is also our vertex. And so we have a picture that looks like this. Ignoring air resistance, we can work out its height by adding up these three things. The height starts at 3. It travels upward at 14 meters a second. Gravity pulls it down at -5 meters per second. And if we add them up, here's the equation. Height over any time is 4 plus 14t minus 5t squared. Is it 4 or is it 3? All right, so this should be, let's change it. Let's change our, since the equation's 4, let's just say our height starts at 4 then. Okay. What height will the ball be at when it hits the ground? Explain where this point is on the graph that you made. Okay, so we have to figure out this right here. The height is 0. We have to figure out at what time is this 0. So we want to know when time is, what the time is when height is 0. So here's what it looks like. 0 equals 4 plus 14t minus 5t squared. Explain how we can use the equation to figure out when the ball hits the ground. And again, my workspace quit on me, so let's try it again. Okay. So we can use this equation when 0 is the height, and we can use quadratic formula to solve. So actually, let's go to this page right here. Okay, let's see if I can go back to this. Okay. So use your equation in algebra to solve the problem. So again, we want to know when 0 equals 4 plus 14t minus 5t squared. We can use quadratic formula. What's a, what's b, and what's c? Now be careful, the equation is shifted around on you. A is the number next to the x squared, or t squared in this case, so a will be -5. The b value is next to the x, or the t in this case, so that's 14, and then the c will be 4. So we are going to plug into our equation x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I tell you to calculate the Three Musketeers. So we're actually going to get this number right here and this number. So we'll have x equals -14 plus or minus the square root of 276 over -10. And then calculate this, hitting enter before you divide. And so one of our times is about -0.26, and one of our times is about 3.06. And since this is a problem dealing with time, we can only use the positive answer. if we take a look at what the last one looked like, remember what our graph looked like. It started here and went up and down. This means the height is 0 at 3.06. That negative would be our other 0, but again, for this problem, it wouldn't make sense because we're starting at a height of 4 and then going up and then down to figuring out when our time is 0. So 3.06 seconds is the time that this reaches 0. Plug your equation into the graphing calculator and use your calculator to figure out when the ball hits the ground. All right, so let's open a new calculator page. Let's type in our function. Whoops, I want calculator page, or graph page, not calculator page. So add a graph, type in our function. Again, it was negative 5x squared. I'll put it in standard form. And then it was our plus our 14x. So I changed our t's to x's. And then it was plus 4. So here's a picture of what it looks like. I can kind of move this down here. Let's zoom fit our graph, menu. If we zoom fit it, looks a little bit better. Oh, actually, let's zoom in. All right, did I type that in right? It was 14x. All right, so let's figure out this right here. So it went up, it went down. Let's figure out this value right here by going to menu, analyze graph, and we want the 0 here. So we calculate that 0, we can see that at 3.06 seconds, the height is 0. All right, let's do the next problem. Area of a frame, and then we'll look at the bacteria. Your company is going to make frames as part of a new project they are launching. The frame will be cut out of a piece of metal, and to keep the weight down, the final area should be 28 centimeters squared. The inside of the frame is 11 by 6. What should the width x be of the metal frame? So let's figure out the equation for this. Keep in mind this is x and this is x. So this distance right here is 6 plus 2x. And then over here, this is x and this is x. So this width is 11 plus 2x. And let's multiply this out. We have 6 plus 2x times 11 plus 2x. And so if I FOIL that or multiply, we'll get 66 plus 12x plus 22x plus 4x squared. And we want the equation after cutting out the middle. So this middle is 6 by 11, or 66. So I'll minus 66 from this. So here our 66's cancel, and we're left with 4x squared plus, and if I add these two together, we'll get 34x. So this will be our equation, and we know our area will be 28. Okay, so let's use that equation to solve and find x. So again, our equation was 4x squared plus 34x. And then instead of this equals 28, let's make one side equals 0 so we can use quadratic formula to solve. So minus 28 from each side equals 0. Quadratic formula, x equals opposite b, plus or minus the square root of b squared minus 4ac all over 2a. Calculate the three musketeers, and when I do that, I'll get x equals negative 34 plus or minus the square root of 1604 all over 8. And I'll get two answers, and one will be negative. So the only one that makes sense here will be our positive, which is about 0.076 if I round. So here x is 0.076. We can use our graphing calculator to put this equation in as well. So again, let me open a new calculator page, or sorry, graph page, and let's type in our quadratic, which was 4x squared plus 34x minus 28. We want to know when that equals 0, and we can see there's one negative answer, one positive. So if we analyze our graph and find the zeros, what we're looking for, and you'll see is that 0.756, which I rounded to 0.76. All right, let's look at the last example, the number of bacteria of a food. Let's just do this all in the calculator. The number of bacteria of food in a refrigerated food is given by this function, between negative 2 and 14 degrees Celsius. Use your graphing calculator to find the temp for when the number of bacteria is minimal. So let's type this in. So I'm just going to hit tab and delete what I had in here before. And I'll type in the function that we're given, which is, let me find mine, 20x squared. It's 20t squared. I'll change the t to an x. 20t squared minus 20t, or 20x, plus 120. We're looking for the minimum value. We don't see it, so let's zoom fit our graph. All right, there's the minimum value right there. Let's calculate it. Menu, analyze graph. This time we want the minimum, not the 0. So our minimum is 0.5, and what that means is at 0.5 degrees Celsius, we have 115 bacteria in our food. So your assignment today will be to practice these quadratics, finding zeros or minimums, and you can use your graphing calculator quadratic formula to solve.